Hi everyone, my name is Hayden and I'm here today to talk about a syntax introduction to JavaScript. Now JavaScript, I'm sure, is a language that you've probably heard about before through your friends or yourself, and it certainly has a reputation both in the positive and the negative. We're not here today to talk about whether it's good or not. I think it's great. We're here to talk about how to use it at the most fundamental level. And a lot of the other things that we're going to learn in this course are built off these fundamentals. So the point of this lecture is so that you can learn the absolute basic principles of JavaScript that you can go and apply out there when we learn about Node.js in the next lectures, and JavaScript in the web browser, and React.js and other declarative frameworks, whatever it is. So we're pretty much just going to go through a whole bunch of examples that should demonstrate language features. There's not really any new ideas in programming that are going to be thrust upon you here. So thankfully we're not explaining concepts, it's very much just a how do you use this language. So starting off with one of the simplest examples here, you have a program and you have block comments and line comments at the bottom. That's exactly the same as the C programming language. One area where JavaScript differs is that to print something to the terminal or the console, you don't use a printf in C or a print like Python. You actually use a console.log. That's like the equivalent of the print function. And in this case here, just like Python, I'm printing both hello the string, and on the next line I'm printing the result of the 1 plus 2 addition, that kind of statement. Now you'll notice that as we go through this, that this will actually be very similar to Python. So if you are familiar with Python 3 as a language and the Python interpreter, you are going to find this very straightforward to pick up. Now, how do we run these things? Well, we can run these a couple of ways. Everything in this lecture that you see today can either be run in the web browser or it can be run on the command line with the Node.js interpreter. And in terms of setting up that interpreter, you can actually go to the Comp 6080 website. Give it a sec. And if you go and log into the site, obviously, like this, and you go to installation, you will be able to see a section on how to get set up for the course, right? So like, you can get set up to run this stuff on a web browser, and you can get set up to run this stuff through the Node interpreter. Now there is a lecture on the Node interpreter, and we're going to talk about that more in another lecture, but for now I'll just kind of show you that you can run these in two places. So let me get those two places up for you. So the first way that we can run this, as I mentioned, on the Node.js command line interpreter. So if you have Node.js installed and you're in that directory like this, I can actually just simply run node 0-simple.js, just like a Python file, and it will execute it and give me the result. So this kind of makes sense. It's like, okay, I'm running this code, I get hello, I get 1 plus 2 is 3. The other place that you can run this code is you can run it inside of a web browser. So what I've also got down here is a page test.html, where I've got an h1 tag at the top and then a script tag at the bottom with some JavaScript. That's how you can run JavaScript on a web page. Now when I have this, you might think, well, this page printed hello, and it's actually printing this top hello, 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 but it's not printing the string hello, or I could call this hello 3, and it's not printing the number 3, and that's because where it's actually printing it is inside the console. So web browsers are a little bit interesting, and this will start to make more sense as we explore JavaScript through the front-end lectures, but with web browsers, when you kind of print to the terminal, there is no terminal to print on a web page because this is like a rendered image. It actually prints to this console that's inside DevTools. But in the end, what's printed here is exactly the same to what's printed here. Everything that we're learning today in this lecture works in both the Node.js interpreter on command line, and it works in the web browser on the console there. We're going to learn in the next lecture about the differences between those two and dig into that a little bit more. But that's enough background. Let's talk a little bit more about the language. So, very simple, I can print stuff to the terminal. The next thing is we're going to have a look at ways you can declare variables. Now, like Python, it is a loosely typed language JavaScript, which means you have things like strings, numbers, decimals, booleans. That's kind of like your base types. Now, there is a bit more than that. In JavaScript, though, compared to something like Python, you can actually declare a variable as a constant or as just a normal mutable variable. So again, in languages like Python, when you just say variable value equals 0, it is by default mutable, and in JavaScript we use the let syntax for that, because the let here is kind of like saying I want to create a variable that can be modified, and the const is saying that it can't be modified. So if you try and run this at the moment, it's not going to print anything because there are no console logs. But if I tried to say modify const value equals by, I'll get an interpreter error that says assignment to constant variable. Whereas if I try and change variable value to by, it works. And you can also see here that I've changed a number to a string, and this is just as you'd expect from a loosely typed language. I can do that because nothing is strongly typed. So that's very simple. The main takeaway there is the const and the let. So next thing are some more complicated types in JavaScript. Obviously we have a constant string, a mutable number. We can also have a notion of what we call objects in JavaScript. This is very similar to what you would call dictionaries in Python, maybe hash tables in another language, but it's essentially a key value store where I've got a key and a value. I've got, you know, my wildlife warrior. It has a name of name, Bindi. It has an age of age, which is 22, and a gender of F, right? It's like it's cisgender here. Then we'll print hello world to console, and now we're printing that to the console. And you can start to see how we can actually use the console.log. So I can print a variable directly in console.log. I can print it just by comma separating it, which will essentially just print it with spaces, or I can print it with age here, plus to concatenate, so this combines things. Unlike Python, you don't have to cast things to a string. JavaScript's a bit more relaxed. And then just another case here of printing out two things with a comma. You'll also notice here that the wildlife warrior, if we try and print out that whole object, you will see that we kind of get the whole object. So if I print out that, we get the Bindi, and then their age, and then we get their name, age, and again cisgender, assuming that someone identifies that way. So that's really the crux of it. You can add more stuff here if you want, such as, you know, height is 170. That will print it out too. These are just objects. Let me just undo that so I don't ruin the code example. Also got some more stuff with types. We got decimals, strings. Strings can be double apostrophe or single apostrophe. Again, just like Python. Which is cool. Things can be null, undefined, booleans, and then a few other things. So in this case, you can see we're constantly reassigning the value, the variable value, because it's a let variable, right? You'll also see that we have this idea of null and undefined. Now, this is actually a really tricky part of JavaScript. Undefined and null are both different things in JavaScript. Undefined generally is trying to say that this is literally nothing. There is nothing defined here. It's the absence of something. Whereas null is, it's very hard to explain. I would say null is a little bit more saying it's a thing, it's just null. So undefined typically is trying to say it doesn't exist, it's never existed, whereas null is a bit, you know, a bit more like it's kind of got a value, and that value is saying that it's nothing. Did that make sense? Probably not, but you know, the main thing and the main trope to be aware of is not to interchange these two, because they're not equal. So if you kind of want to represent nothing, using undefined for that or null's fine for that, just don't mix those two concepts together. There are a bunch of other things that you can look into in your own time, like this symbol function. But the point is that it doesn't have to just be primitive types. It's like other object-based languages where things can be numbers, or they can be whole objects, or they can be lists, and various other things. So now we'll move on to a slightly more interesting part of this, which is functions. So if we have a look at functions, JavaScript is very interesting in that there's kind of multiple ways to define a function. And this is both a great and a troubling thing. So one thing you'll see here is that I've got these three different types of functions. Now I'll just quickly take you through essentially the three formats of a function in JavaScript, right? So firstly we have, if I have a function called add, where I give two numbers, and it's going to console log those two numbers. 1 and 2. Now, the sum of those two numbers, right? Very, very simple, silly function. I can call that function like this with 1 and 2. Now, I'll just comment out the rest of the code, which we know how to do. I'm going to run that. I'll just run for functions, and I get 3. The other way you can write the add function is that you can write it like this. You can say that const add equals function like that, and it's the same thing. Now, I'll have to change the names of one of these, but this syntax difference I think is really interesting because it's going to tie into a concept that we're going to cover at the end, which is the idea of first-class functions, or the idea that functions themselves can be treated like variables. Because you can see here what we're saying is not that there's a function called add, but that there's a variable called add, and that's equal to a function. And this will do the exact same thing. There's your output. The third way, which is the way that we probably encourage you to write because it's a bit more modern, is you say const add equals 1 to like this. Now, what's the difference here? Well, it's really simple. It's a lot like the second format, except the function has disappeared, and there is a equals greater than sign between the parentheses and the braces. It's just a bit more compact, and that also gives you the same result. So they're like the 3 different ways to write a function. The main benefit of the last way is that it's more compact, which is very helpful. So if we have a look here at the functions, you can see that we've got, I've already let value be something up the top, so I can see here that value is a function with 2 parameters. It just prints those 2 things out. And then here I can say value equals function. So a very similar thing, just like the methods I had before. We're letting this be a function with 1 parameter. And now we have another function that takes in bar and returns that. And then this is where we start to understand that functions can return things, just like every other language, right? It's not just about console logging. Like in all of these cases above here, these are functions that do something. They console log, but they don't return anything. This function actually returns something. So in the previous examples, I was just calling add like this, but I wasn't doing anything with a return value because it didn't have it. Whereas here I'm actually saying, you know what, the result is actually equal to foo10. So now I'm passing 10 into the foo function, and it's going to return me the parameter bar plus 1, which means result here will be 11. And then I'm going to pass the result 11 into value, and value is defined as this function here, which should print param equals 11. You know, so you can really trace this logic through if you want to. And then at the end here, I'm not 100% sure why this is shoved at the end, but I can't remember. But it's just to point out too that whilst there are certain number types in JavaScript and string types, and it is loosely typed, you can still kind of cast things a little bit like Python. In this case here, I'm like, I want this to be a big integer. We don't really cover this much, and there's no real need to kind of have us teach it to you because it shouldn't be super critical, but it is also something else worth noting. So we've been talking a little bit about types, which really leads us on to the next example, which is looking at the type of function. Now, this is a bit of a built-in function in JavaScript, and even though, just like Python, even though there's no types that you declare in JavaScript, JavaScript still has a notion of a type. For instance here, if you were to create a value 0.1 or a string or null or undefined or true or symbol, all of these, if you tried to get the type of, it will actually print out a value. Like it'll print out, like, so what type of does is it takes a value, like a variable, and it prints out the type of that variable, which would in these cases be number, string, object, undefined, boolean, right? So you can see null here is actually an object. Now, when you hear people complain about JavaScript, most of the time what they're complaining about are quirks of JavaScript. For instance, it's kind of strange how null is an object, right? Like that's a bit of a strange thing. Undefined being undefined, true being a bool, all of these other things make sense. If you look at other types of objects, such as this one here, you create other types of variables. You create an object here with key, has value key as a string, another key which has value 10 as a number. If you try and print the type of value, you're going to get object, which makes sense. Very strange that this and null have the same type, for instance. You have type of function when you create a function, and if you do some other kind of manual casting like big int or int, which we're not going into in this lecture, you'll also get those various types. Speaking of undefined and null, there's certainly some very strange behavior of these things. Now, if you create a variable, if you declare a variable but you don't define it, like we have here on line 1, then the type of that variable will be undefined, like that. Now, here's where things get a little bit tricky. I think this might be in a later example too, but I just want to cover it here briefly. If I say that const A equals null, and I say that const B equals undefined, here's what you'll see. If we print both of them, you'll see that they print out somewhat as you'd expect. We get null and undefined. Where things get kind of weirder is if we check if is A equal to B. That's true. Okay, well this will come into play in the next couple of examples, but keep that on your mind, right? So on the topic of types, continually we've been talking about big ints and strings and saying how we can convert things. This is how you actually convert some of these things. Now, the third and fourth example here, you don't need to worry about too much again because you don't do a lot with big ints and numbers. But one thing that you'll do often is converting numbers to strings and strings to numbers. So in this case here, if I've got a number called 10 and I want to convert it to a string, right, I can just say, well, string value is equal to value dot toString, which in this case is like going to output a string. And you can kind of compare the value, right? Like compare the types. If I print these out, you'll actually see what's it complaining about? Num value has already been declared. I'll call that one num value 2. Right, I get 10 and 10, and you actually see that the node interpreter can tell that one's an int and one's a string because of how it's printing it on the terminal. So 10, the yellow text in this case, is a number. And then similarly, I can take that string 10 and I can convert it to a number. Now, this 10 you see here has nothing to do with the initial value. It's actually all to do with the base. It's a little bit weird, but essentially when you turn a string into an int, you actually want to tell it what base it is. So in this case here, if I had 50, and I try and console log num value, you'll see that I will get 50. But if I put this as, let me say 100, right, like that, I get 100. But if I change the base from 10 to 2, I'm going to get 4. Why do I get 4? Because what's base 2? Binary. So now it's trying to like convert this value up here, which was a number, to a string, the string 100. And then we're trying to convert that string to an integer base 2. A bit weird, honestly. I've never used that before, but that's what that number's for. So it's there as 10 to say base 10, which is kind of what you just call a number. So that's kind of there as you'd expect. So parseInt and .toString are how we move between them. And then we got onto comparisons. So we've been talking a lot about strings and numbers. So where things get very strange is on comparisons. Now in JavaScript, there are two ways to compare values. You can compare with a double equals or with a triple equals. Now in this case here, if I have a value 10 and another value, the string 10, are they the same? Well, it depends who you ask. So if we have a look at these first two console logs that print to the terminal here, you can see we get true and false. So how the JavaScript equality operator works is that a double equals is referring to whether the value is the same. Whereas the triple equals is checking whether the value and the type are the same. Now you might think, well, how are 10 and 10 the same value? Well, it kind of makes sense. They're both 10. They're both 1, 0. Like maybe think about it a bit more. If you converted them all to a string, would they be the same? That's kind of what they might mean, not literally with, is the value the same? Whereas triple equals is, are the values and the types the same? Now, what this means is that you should always be using triple equals. There's pretty much no scenario where you would want to use double equals. If you only care if the values are the same, you should take the time to just convert that to the same type so that you can use triple equals. The reason we like to avoid double equals too is because you get strange things like this. See here how I've got this string called object, and here I've got this this other thing here, this object with cats say meow and dogs say woof. The problem here is that if you compare those two things, when JavaScript tries to turn an object to a string, you get this, right? I'm not sure how to do that off the top of my head. I think you might be able to say like console log, can you do this? Can you do string A is A? Let me see if this works. This is impromptu. Yeah, see, you get that, right? So if I try and print that object as a string, I get this, I get a literal string with all these ASCII characters in it. So here's the funny thing, if you try and compare if an object is equal to that string, it's actually true with the double equals, because JavaScript coerces the object to a string and then compares the value and it looks the same. But the types they started with were different. So that's why that's another example of why we really want to use that triple equals whenever we can. So then the next part here is we're going to learn a little bit about, we've kind of done this like really deep dive on types, right? Just like types, true and false, bool and undefined. Let's talk a little bit more about structures. So we've already explored the idea of an object, right? Dictionary, whatever you will, where we have over here, a series of keys and pairs, and we understand that we can print it. What we haven't talked about is accessing it. So again, if you lean on your Python knowledge, you can access values within a dictionary through its key, like this with the object. So the object by the key is a value. The next thing, right, is that you can also do it just with this dot. So you can say like either key with the braces and the apostrophe, or you can just say dot. These are literally equivalent. I think you would argue that maybe this one is a little bit cleaner. The benefit of this one though is obviously that you can inject variables. Like I could say like const key equals key, and then I could actually put key in there and treat it as part of a loop. You can't really do that with this method very easily. But they're both kind of the same and they're both able to be used interchangeably. Lists or arrays in JavaScript are exactly as you'd expect, and very similar to Python. There is no distinction between arrays and linked lists. There are just the idea of lists, or I think they're more commonly referred to as arrays, but it doesn't really matter. Very similarly, it's like they can be a collection of any object type. Generally, you use the same type, all numbers or all strings or all this. In this case here, though, we're kind of saying, well, let's get the first element, the 0th index, as you'd expect. The type of it is an object. A little bit weird, right? There's no different typing for objects, dictionaries, and lists arrays, but that's okay. And then to get the length of the array, it makes sense that it's just a property of the array. So if you start thinking about arrays or lists as, typical objects like in an object-oriented language, then this is just a property of it that will give you the length. That makes a reasonable amount of sense. In newer versions of JavaScript, there are also explicit map and set types, which essentially are, think of them like wrappers for like the base JavaScript object up here. You do not need to use these, but you can. A map, as you would expect, is essentially a key value store. A set is just a key store, where you can add a key, check if a key exists, remove a key, and a map is very similar, except you're adding a key value. You can check if there's a value at that key. You can remove a value at that key. You can, the key and the value. You can look into those more if you want. They exist. They're in the, they're not in the old school versions of JavaScript, but they're still there. So, yeah. Moving on to the next bit. If we move on from collections, right? So we've been through types and comparisons and collections. We're going to start getting onto logic for the next few examples, probably like the next 5 or 6. So the first one is if statements in JavaScript. Exactly like what you'd expect, pretty much the same as C, to be perfectly honest. You've got your if else, your if else. You can do if statements without the braces. You can just say if condition and that, and it runs the statement on the following line. So very simple stuff there. You've got switch statements. Again, I'm pretty sure this is basically identical to C in terms of its structure and layout. Obviously, the language itself is a little bit different, but fundamentally, the flow is the same, case and break. So again, not going to cover that very much. One thing that starts to pull it away from languages you might have worked with before is some of the ternary statements. So you've got like ternary if statements here where you say, condition, you give it a condition and then it executes something if it's true, otherwise if it's false. So a good example here is, if I say, too old, or like a grade equals, and then I give it a condition which is like mark is less than 50, then I say it's a fail, otherwise I say it's a non-fail, like that, so I say const mark equals 45. And this is really the equivalent of an if-else statement. Generally, where we use ternary statements instead of if-else statements are when it kind of follows a pattern where it's like if A, then return B, else return this, i.e. there's not like different logic. So you can see here the logic for the if and else case is exactly the same, and it's kind of being reduced to a single value. That's generally where you use ternary if statements. Used extremely commonly throughout JavaScript, so it's something you should get very used to. A few other things that you'll see, I don't think we'll talk about these until later when we do some of the declarative framework React stuff, but you can also be a little bit cheeky with JavaScript if you want to. And let's say we want to, for instance, someone has a mark of 45 and we want to print their mark, and I say, you know, node 13 here, result. Oops. You know, there's a few, condition is not defined. Oh my lord. I don't think this code was meant to be run, I'm sorry. I'll add a note up the top. Not meant to be run. But if I just take this first little bit as an example, because this will print for us, right? Here I get the 45. What I can do is if I want to only print fail when someone fails, normally you do something like this. You say if mark is less than 50, console.log fail, like that. Whereas if I want to make myself, you would argue this is a little bit ugly, but you could also actually just say this: mark is less than 50, end console log. And what this is relying on here, because you see we get the same result. What this is relying on is just the standard programming short circuit approach, whereby the language is treating this like an if statement, right? You know, with an if statement, you say, you know, if A and B, but what's happening here is that this is just executing as a statement, and this condition is being executed, and only if it's true do you execute the second condition. So this whole line itself here would actually return a value, but we are discarding that return value. We're just kind of leveraging the AND logic here. So if mark is less than 50, then we go and console log this, like that. So, you know, that's just a little bit of fun. That's not something you need to worry about, but you will recognize that later, probably like in week 7 when we talk about that. So the next few examples are to do with what we call the truthiness of a value, which is kind of a funny term in JavaScript, but truthiness just refers to whether something is true or not. And it's funny that this is a topic at all, but it has to be a topic in JavaScript because its truthiness behavior is very strange. So you can see here, true is true, that makes sense. False is false, always, that makes sense. Any string is always true. Any non-empty string is true, an empty string is false. A string of 0 is true, and the number 0 is false. Right? A little bit funny, and the reason, you know, it's funny is because obviously if we console log if 0 equals 0, it says true, right? Like it thinks this is a true statement. Even though, you know, you check that, like, it's funny, right? Like, think of it like this. It's like 0 and 0 have the same value but a different type. Okay? If they have the same value, in theory, they should give you the same result when you do an if check, but they don't. So the value n type 0 gives a different conditional result. It's very strange. And to be honest, again, these kind of make it look like, oh my god, there's so much you have to remember. But in reality, I don't think about this. You're not going to think about this. And you're just going to try it out if you aren't sure. This is more just trying to point out that there are some obscurities that you need to keep in your mind. Some other examples. Every number except for 0 is true. Null and undefined are falsy. We call them truthy or falsy. So null and undefined are falsy. All objects like this are truthy. All symbols are truthy. All functions are truthy. And you can kind of see it. What this has really gone down to is that the 0 number, empty string, null and undefined are all falsy, and everything else is pretty truthy. So it's fairly logical overall. And then just a few other examples here. a few of my favorite ones here, because they do some strange things. I'm going to skip over. Like, there's a couple at the bottom. Like, if you go and create a new string or a new number, they're always truthy. And you might be thinking, what in the world is that? It's a little bit confusing, but essentially this creates a string object. And again, you might be thinking, what's the difference between that? Well, let's try it out. What's the difference between Hayden and console log new string Hayden? Let's see what the difference is here. Okay, they're both kind of strings. One of them is a strange string object. Generally, again, you're not going to interact with string or number objects, but if you use Java in like comp 2511, you might understand that there is a difference between, say, a primitive integer and a object integer. It's kind of a similar thing here, but again, don't worry too much about those bottom two. The ones I really want to draw your attention to show you how strange JavaScript can be are these two. And what these two are is this. What this is showing you is that when you try and take the string 1 and subtract the number 1 from it, what JavaScript does is it actually coerces the string, I believe, to be a number, and then it subtracts it. You can see we get the 0 there. So it coerces a string to a number, subtracts it. The result of this is 0. 0, the number, is falsy, so that never prints. On the opposite side, well, on the same principle, if you take the string 0 and you plus it, like a unary plus, what happens here is that this turns in, this gets casted to a number 0, and then the plus turns it to a 1. I think, actually, why does that one never print? I think I might have mistaken myself there. So if we do this, we get 0 as well. Oh, sorry, yeah, the plus doesn't, sorry, it's not addition, that's very silly of me. That's like minus, right? So like if you put a minus in front of a 0, it turns it into minus 0 or plus 0. Very, very strange there. Again, those two examples are not something that you have to think too much about. So, but that's the background on some truthiness of things. If you ever want to find out what the truthiness of anything is, you can kind of just console log it. If you want to, but if you want to actually see how truthy it is, you can do the coercion, which is the double exclamation mark, and then what you want to convert. So if you want to see whether 1 minus 1 is truthy, you can do that, and it will show you that it's not. That's kind of a shorthand way of getting a true or false value without having to write if statements. Anyway, enough of that. The last few examples have been very theoretical and just trying to tease out the language. But let's talk a little bit more about language features. So we move on to loops. Now, loops in JavaScript, again, thankfully, very, very similar to C. You can see here we've got our for loops, our while loops, our do while loops, which to be honest, I don't think anyone uses, but you get the gist. I don't think there's a lot to say here. It's pretty much identical to C. So thankfully, you can reuse a lot of that knowledge. Granted, JavaScript does have some like for range loops that are Python-like, in the sense that if I have say a list of names, like Hayden, Jake, Emily, like this, then I can do a for loop const name of names like this. Now, I don't think we talk about this very much in the other slides, so I'll just quickly mention it now. What this will do for you here, if we look at just the bottom parts, sorry, again, a lot of this code wasn't meant to be run, so it's getting very confused. Hayden, Jake, Emily. So the syntax is a little bit weird, but essentially it's saying that take a list, and then for each item in that list, we want you to take that item as a variable called name. The one subtle difference is that if you use of, it goes and gets each value. If you use in, it goes and gets each index 0, 1, and 2. So if you're looping through a list, typically you want to grab the value, not the index. And a similar but opposite thing is true for a dictionary. If you have, say, or like an object, if you have, say, name is Hayden and age is 20, not 20. Where if you say for const attribute of attributes, the dictionary, let's console log what happens here, it doesn't like it, right? That's because the way that objects are set up is a little bit different. You can see though that if I loop over use the in for objects, I get the key instead of the value. But I can then use that key to look up the value like this. So, you know, I go through all the keys and I print out the values like that. Now, there's a little bit more to this, but just to start you off, they're just the considerations to think about. It's just, you know, you can do this like for range style looping in and of if you want to. There is a lot more to the looping stuff there, but that should get you through pretty easily. Newer versions of JavaScript have classes. In this case, we've got a class called snack. I don't think I want to spend much time on these. You can work through them in your own time because they're just not used that commonly, but they're as you kind of expect. You can have constructors, you can have members, you can member functions, you can have member fields, you can use the this dot operator. There's another example with classes. You can use inheritance, so one class can extend another class. You can use static variables. You can do super construction. So again, a lot of this would rely on knowledge that you might have acquired through like an object-oriented language, such as Java would be the classic example. Though a lot of Python carries through here as well. Instead of self, you have this. So it's all relatively straightforward, but that kind of is the crux of it. Some other examples here. Now we're looking at a meal class where we have a constructor that takes in a list of snacks and it populates like a class field with that list of snacks, and then we've got two methods here, an eat sum and a log calories, and the eat sum just goes and loops through all those snacks, the log calories loops through them as well, and they both just do different things with it. Should you use classes in this course? Maybe. I don't think you're often not doing things that are super front-end logic heavy, but you can definitely try to do it if you want. The one downside of classes is they tend not to be JSON serializable, so it's very hard to like export it to JSON, but that's okay. And then the fourth example with classes here is that how you might create that class. So if I just go and say copy and paste these together like this should work now. Pizza, that's all right. We'll just say that, like, you know, snack is 800 like this. That's okay. A lot of this code, by the way, was never meant to be run. I'm just feeling in the mood to run some of it, but there's a little bit of like, we're missing the other classes here. So what we might do really quickly is just slap all of these things together in a single file. I'll go and take that and I'll put this one in this one too. So now we've got our snack class, our pizza class, our crisps class, our meal class, which should use those. We create a list of snacks, which are pizza and crisp. We create a meal, pass those snacks in, and then we call a few member functions on it, and then we get a result, right? So here, like, I mean, I'm not going to take you through what all of this is, but have a look at the type of, if we print out the type of meal, which was a class, you can see that we get a function. That's interesting. Think about that. It kind of, what it does there is it shows you how JavaScript designed classes. They're basically very sneaky function closures. We'll talk about closures later. But the type of meal is an object. So if you think about a class as essentially a factory, like it's a function that produces a new object. Meal itself is a function, and then meal, meal, you know, uppercase meal class is a function, lowercase meal variable is an object that gets created. So there's a little bit to classes there. Last few things, we have a Fibonacci example here, where this is just showing you how you can combine a few ideas like if statements, returns, loops, function calls. This is an iterative Fibonacci. Super fun, I guess, but again, not a lot to talk about here, just showing you that you can do some interesting things with the language. And then the last kind of two big things I want to run through are, firstly, MapReduce and filter. What MapReduce and filter are an idea where there are three really common things that you do when it comes to data manipulation, in particular lists. One is to take a list of 10 items and go and convert it to a list of 10 modified items, or it's to take a list of 10 items and to select some from that list. Now, if you've done Comp 1531 at UNSW, then you've probably been taught this before, what MapReduce and filter are in the context of Python. If you haven't done it before and you're a postgrad in particular, you don't actually need to know any of this either, and I'm making it sound really hard, but it's not. But the whole idea is that quite often, because you can go and look at this example in your own time, but quite often if you have a list of numbers like this, and you want to go and get all the numbers that are less than 5, right? This is what you might do. New nums equals empty list for const num of nums if num is less than 5, new nums dot push. Push is an array function. It's like append. You push to the end, I push num like that, and then I'll just console log new nums. And then this will be the first number that we print out. So we've got 23 like that. You can see 1, 2, 3, 4. Filter is a much quicker way to do this, where I could say new nums2 equals nums dot filter, and then what I do is I give it a function to filter that with, right? Now this is going to tie into our next bit with the idea of first class functions, but in JavaScript you can actually pass a function in as a variable. So here I can call dot filter on a list, and inside of that I'm going to give it a function to sort it. So I'll create a function called less than 5. And what that's going to do is going to take in a number, and it's going to return where the number is less than 5, like this. So now I'm going to pass that into filter. And then I'm going to console log new nums2. It's actually relatively straightforward, right? And it makes a lot of sense by saying like, okay, take nums the list, filter it, which means go get all the items, search through them, well, go through one by one and choose whether to keep them or not. And it always returns a new list too. That's a really important thing about like filter, is that it's not modifying anything. It's always returning new items. And this less than 5 function that's being passed in, it's calling every time it checks against each item. We can also make this more shorthand. We can say const less than 5 equals num with the new function syntax, right? Same kind of thing. Again, we're printing out this line here. We can make this even shorter, and this is why this example exists. In JavaScript, if you omit the braces, it will return the next the next line. So this is really handy for one-line functions. So if your function just has one line, you can omit the braces, and what it will do is it will return that next line, and therefore you can drop the return statement. So suddenly, if I take something like this, right, like that, and I just give you like a shorthand example, these two things are actually equivalent. Less than 5 there is like that. Since this line is so short, it's very common practice to actually go and pop it up on the next line like this. And then, what do we know here? Well, we're passing this function into this filter function. We're passing a function in as a parameter, but all this function is just this here. So I can literally copy and paste that and put it in there, like that. And it's a very strange series of steps that got us to this point. But if you take the time to go through them, it's like, oh, actually that makes a lot of sense, because what happens is filter's taking a function, and that is simply a function that has parameter num, and it returns the result of num is less than 5, which is a Boolean value. And this is cool because somehow we've gone, now we've gone from this whole thing to filter numbers less than 5 down to this, right? Very, very elegant. You could make this even more complicated here. For instance, like, what do we know about this? Well, we figured out that this is a shorthand way to do a function. I could say, number has to be less than 5 and greater than 1, right? So again, I could just go and take that whole thing and just dump it right there, like that. And there's my, that works the same. With JavaScript functions too, if your function only has one parameter, you can actually drop the braces as well, like that. That's optional. You don't have to do that. But, it's something you can do as well. So that's filter. I'm explaining this in the assumption that you understand filter, map, and reduce, but you haven't used them in JavaScript. If you aren't familiar with them, you should probably go spend some time Googling them. But I'll just quickly demonstrate map as well, because they're the two most common you use. Same kind of thing with map. If I want to say turn all these numbers and double them, I would go and say create a function called, well, this is the old school way to do it. You'd say new nums, and then like for each number you would like push number times 2, like that, and then you print it out. But the shorthand way is you would say nums.map, and then you would maybe pass in a double function. I got my function double, which takes in a number, and it just returns num times 2. But if I use the new function syntax, const double equals function, and then like the newer function syntax, const double equals that, and then I can drop the parentheses around the parameter because there's just one parameter, right? And now because there's only one return line, I can drop the braces in the return. And now because the function's so simple, I don't really need to define it. I can just go and put it here. Now we've got this really powerful shorthand way where we are able to take a list and simply double all the numbers in it. Like that. So now we've got, a list of 2, 4, 6, 8, 10, 12, 14. So it's really, really, really powerful. Map and filter. And I would strongly recommend that you get comfortable using them. This example here is one you can look through in your own time where it shows you how you can go and take numbers and get the even numbers, get the positive numbers, get the numbers over 400. I don't think there's any mapping here, but that's okay. A lot of filtering and reducing. So map in particular, I think, is a really, really, really common thing to use. So get comfortable with these things. That ties up this example on like map and filter, and also gives you a bit more background on JavaScript functions in terms of, parameters and shorthand functions. I try and save those for the end because earlier on I think, we're just trying to cover the basics. But this leads us to our last bit, which is on something I've just done there where I passed in functions as variables, and we're going to make our own example here to demonstrate this concept further because it's really important to understanding lots of things that are subsequent. So first class functions are a really interesting idea. You'll see these on the internet if you Google it. Like when I say first class functions, again, it's just a fancy way of saying that in JavaScript functions can be treated as variables. And what I mean by that is if I create a function here called greeting, and all it's going to do is return hello, right? Or again, just to really emphasize this point further, let's make it shorthand. Const greeting is just a function that returns hello, like that. Then I can go and make another function called print name, which can take in a function and it can take in a name, and it's just going to console log the calling of that function and the name, and then I can go and call it print name with the greeting function. I should call this like function and the name of Hayden, right? So and this is something that we will use extensively and is very important to getting your head around. So, and again, I could simplify this further if I wanted to, but I don't think that makes it any clearer. It's kind of just starting to get a bit confusing. And in fact, I might even just undo that so it's a little bit easier. By the way, JavaScript's pretty relaxed about semicolons if you haven't noticed already. Like here, I didn't have semicolons, I do. It's alright, it'll figure it out. So yeah, there I'm printing hello Hayden, and you can take this like further and further, where you could put it, you could have greeting take in a function, Actually, this will like really demonstrate the point. So you might get this. I'm hoping you get this. You think, okay, well, greeting's a function, print name is itself a function that takes in two variables. One of those variables is a function, the other one's a name, and it does stuff with them. Now, the naming doesn't matter. In fact, if I just don't call it, like JavaScript doesn't think, oh, I'm getting a function and a name. JavaScript just says, I'm just getting two variables of stuff. So it gets two variables of stuff, and when I just print it normally, it says, oh, thanks, one of those is a function, the other one is a string name, there you go. If I try and call this as a function, I get a result. If I try and call name as a function, JavaScript gets confused. It's like, name is not a function. I don't know what to do there. So this example is relatively straightforward. Where things get strange is when we start to like layer functions on top of one another. And what I mean by that is imagine that your greeting function takes in another function, right? So greeting takes in, say, a function that's like, what would you say? Second part. And what happens here is like we return hello plus a space plus the result of second part. And we call that. Okay. And now down here, let's keep things really simple. I could say, well, I'm going to simply call greeting now, and the second part I'm going to give it is another function, and that function might be like print there. This will just return there. You know, so it's trying to do hello there. So now it's like I can call greeting and I can give it the print there function, and then if I console.log greeting print there, I'm going to get, you know, hello there, like this. And then you think, okay, well, what happens if I want to pass that greeting into print name? Well, here's what you can't do, and you have to be really thoughtful about this. What happens when I do this? Now, you might think this makes sense, okay? I've got print there, I might move that up the top. Cool. I've got another function called greeting, which takes a function and says hello, and then the result of that function. Now I've got a print name function which console logs the result of a function and the name. So when I call print name, I want to give it greeting, which expects a function, print there, and I want to give it my name. But this won't work. I get an error. It says function is not a function. And the reason for that is because what we've done here is we have not passed a function into print name, right? I'll just call this arg. Arg here is not a function. Arg is a value. Because greeting returns you a value, right? It returned hello there. So what we actually need to return, bit weird, is a function. And all that function's going to do is return greeting. Very confusing. Hello there, Hayden. This kind of intimate understanding between functions and values is really, I think, one of the biggest things that takes a moment to get your head around. And the idea of passing functions through functions and those functions through functions. And wrapping functions in other functions. And I will talk about this a little bit in the closures lecture, so you can go watch that after you watch another few. But the idea here is very simple. Here I've got a function that returns another function that passes in another function. And all of this, the point is that all of these things are variables. I can go and print them out. I can go and print out print there. I can go and print out greeting. I can go and print out print name. I can go and print out arg. All of these things, I can print them all out. They're all functions. But I can treat them like variables. You know? And I think just whilst we're on this topic, to really reinforce the point here, a really common thing that you will do by accident is that something will expect a function from you and you will give it a value. So please keep that in mind. And what I mean is that if you will have a print name function and you will come along and you will do exactly this. You will say, yep, print name, greeting, hello there, right? Because we know greeting does hello and there, and then you'll give it the name Hayden and you'll expect this to work. You'll be like, yeah, that should work, and you'll get this error. In fact, if it's in the browser, sometimes you won't even get this error, depending on what you're doing. So how do you get around this? Well, we've done this already. I don't want to loop through it again, but what I want to explain is that if you're new to it, you're probably going to do this, what we did before. You're probably going to say like my function equals, and then you're just going to return greeting. Then you're going to pass that in. But, and I'll just keep the original line up the top here so that you can see what we used to have, like that. But what do we know about shorthand functions? If I take this, because it's a one-line return, I can just get rid of the braces and do that, right? And because it's so simple, I can just take the result of my function and copy it in. And what do you notice has happened here? The line is like exactly the same, except that we just have this random parentheses and equals arrow equals side bracket there, which at first you might think, oh, that's really weird, but it actually makes sense because this one here is the calling of a function. This one here is providing a function, and that function's job is to call something. So this subtlety between, you know, calling a function and providing a function that later calls a function is really critical. But again, we'll talk about that later. This is probably a little bit confusing, but it will start to make sense, and hopefully we've just canvassed the background. Anyway, that covers like a lot of the basics of everything we want to talk about. So hopefully you feel confident to go and write some simple JavaScript with Node or some simple JavaScript in the browser. And thanks. Have a great day.